So there we go. Okay. What polynomial function is this? Okay. It goes through 0, 3, and 215. Which of these would go through 0, 3, and 215? Well, I'm thinking it's A, B. Oh, really? You're going to do this to me? Okay, so let's get out of this page, go back to that page. There. And now they're there. Craziness sometimes. So y equals ab to the x for an exponential function. Okay. So we have 2 points. So we plug them in. So the first one I'm going to plug in is the one that involves 0. So 3 equals ab to the 0 power. Well, b to the 0 is 1. So a we must know is 3. So then we re-plug it in, y equals 3b to the x. Now let's use 215. So the y value 15 equals 3 times b to the second power. Then we just divide by 3. So b squared equals 15 divided by 3 is 5. Okay. So b equals 5 to the 1/2 power. If we take the square root of each side, it's 5 to the 1/2. Are we good with that, Grant?
Yes.
Okay. So b equals 5 to the 1/2. So y equals a times b to the 1/2 x. Okay. Which one is that? B. 3 times 5 to the 1/2 x, or x over 2. Okay. So you just take it step by step. Now, could you take each of these answers, put them into your graphing calculator, and see which one matches? Yes, you could. Okay, but this is a proper way of solving this. All right. Again, if I were graphing this, I would graph this on my graphing calculator first. Okay. They want to say, well, compared to y equals b to the x, what happens to this graph? Well, what's y equals b to the x in this case? Well, it's y equals 9 to the x. Okay, because it's 9 to the negative x minus 3. So compared, our base function in here is y equals 9 to the x. What does 9 to the x look like? Well, when x is 0, y equals 1. When x equals 1, y equals 9. When x equals 2, y equals 81. So we're looking at y equals 9 to the negative x now. Well, when x is 0, y is still 1. When x is 1, y is 1/9. Because 9 to the negative first power is 1 over 9 to the first, which is 1/9. 2 is 1 over 81. Okay? And then y to the equals 9 to the negative x minus 3. You take these same numbers that we just had, and then subtract 3 from the y value. So it's 0, negative 2, 1, negative, what it would be, negative 2 and 8/9, and 2 and negative 2 and 81st. Okay? So the graph should be this one in the end. So we should cross at 0, negative 2, and 1 just a tiny bit lower than that, and 2 just a tiny bit lower than that, and we're going really close to negative 3. Well, that would be B, correct? Okay. So then, so the graph is a shape of the 9 to the x power would be 0, 1, 1, 9, 2, 81, way up there. So the graph originally looks like this, okay? Originally looks like this. Well, what happened when it looks like this? Well, we flip it around the y-axis. So the negative in front of x flips around the y-axis. Okay? Because you see we turned it and then brought it down by 3. Turned it, brought it down by 3. So it's shifted around the y-axis, reflected over the y-axis, and shifted down by 3 units. Okay? So you just look at what happens here. Okay? If it's a negative right in front of where x is at, we're flipping around the y-axis. A negative in front of everything shifts it around the x-axis.
When we flip around the epsilon, the y, I'm sorry.
Yep.
Doesn't it just go like from this to this? Not.
So when we flip around the y-axis, this one, let me do it in a different color. Draw, boom. It would go like this. Okay? And then we're just dropping it, so then it looks like that. Okay. Is this growth or decay when it's 0.4 to the x? Decay. It's decay because the base is between 0 and 1. So what does that look like? What does 0.4 to the x for 0.4 to the x look like? Well, when x is 0, it is 1. When x is 1, it is 0.4. When it's 2, it is 0.16. Okay, something like that. I don't know what it is exactly. So 0, 1, 1.4, 2.16. It's going like this. And then this is going up like this, probably. Okay? So then, as we go towards negative infinity, where's it going? As we go this way, where's this going? Up to infinity. As we go towards infinity, where is this getting really, really close to? 0. Okay? So those are your limits. In AP Calculus, we start out the year with limits and do lots of limits. All right. Petri dish culture after T hours is given by this. Okay? Initial number. What is the time when we initially start? The time equals 0. Time is 0. If you put a 0 into the exponent, what's e to the 0 power? 1. What's 1 times 700? 700. So your initial should be this number right here. Should always be that number right there. After 6 hours, this is a calculator question now. You put the 6 in for the t. Okay? Somebody with a calculadora, por favor. 700 times e to the 0.698 times 6 power. $46,124. Okay, it goes up by a lot really quickly. This one, exponential growth or decay? Growth or decay with this one? Decay. We look at the number with the variable as its power, not at the other one. We look at this one. Okay? It is decay. By how much of a percent is it decaying? 9%, because you take 100%, which is 1 minus 0.91, and you get 0.09, which is 9%. Okay, exponential growth or decay? It is a growth because r is greater than 1. What's a percent of growth? What's our percent of growth there? 15.2%. You take the 1.152, move the decimal over 2 spots, 15.2. Determine the exponential function that satisfies these conditions. Initial value of 19 decreasing at a rate of 50% per year. P sub t equals, what's our initial value? 19 times 0.50 to the t power. Why didn't I put it to the x power? Because it tells me right here, t represents time. If you put an x in there, it'll count it wrong in the quiz. Look for what it's asking for. Okay? This one, initial value, 453,000 people. It's decreasing at a rate of 3.3% per year. So we're taking it times 0.967 to the t power, not to the x power, because t for time. How did I get 0.967? 1 minus 0.033. Okay? This one, what's my initial value? What would be my initial value here? 2.6. Wherever 0 is, that's my initial value. So it's 2.6 times, okay? Then my value at 1 is this, okay? So I know y equals 2.6 times b to the x. So 3.39 equals 2.6 times b to the first power. So I just divide by 2.6. Somebody with a calculator, 3.39 divided by 2.6. Round to 3 decimal places, please. 1.304 to the x power, using x as a variable. So the last problem used t as a variable. This one uses x as a variable. Make sure you read the directions when you take this. Okay. Our initial value on this is listed where when we do these problems? On the top. Our initial value will be listed on the top. Initial value is 9. So it's either C or it's B. Okay? The limit to growth is 63. So we have to take, or did I say that wrong? Our initial value is what you get when we put in 0. So that makes this 1 plus, our initial value is when we put in 0. So it's 63 divided by 7, which gives us 9. This one is 63 divided by 7, which is 9. Our limit to growth is on the top. And then our initial value, if this is 0, that makes that 1. 1 plus 6 is 7. 63 divided by 7 is 9. Okay? So that gives us our initial value. Our limit to growth would be the top number. This one, 1 divided by 10 is 6.3. So that's why this isn't the answer. So it would be D. Okay? All right. In 2000, the population of a city was 685,000, increasing at a rate of 1.49% per year. At what time will the population be 1 million people? This is what I would do. I would put this on the graphing calculator. My Y1 would equal 685,000 times 1.0149 to the x power. And then under Y2, you'd write 1 million. Then under window, I would go my x min, I'd leave it as -10. My x max, I'd throw in 100 there because I don't know where it's going to be. Y min, I'd leave at -10. But my Y max, I'd change to 1,200,000. Okay? So if you do all that, you'll find out where those two cross. Let me just do that really quick on the graphing calculator. Zoom to my graphing calculator. So Y1 is 685,000 times 1.0149 raised to the x power 1 million into Y2 Yep. And then my window, I'd go up to 100 here and 1.2 million here. And I graph it. Zoom. And then you go second, trace, find out where they intersect. And their intersection is at 25.58 years. So 26, because they want a whole number. We good with that? Okay. Use the population mile graph in the figure to explain why the population doubles is independent of the population size. Okay. So initially it's at 50,000. It hits 100,000 at 4 years. So the time for it to double is 4 years. The doubling time is 4 years. Okay? The time required for it to grow from 50,000 to 100,000 and from 100,000 to 200,000 or twice that size. Regardless of the population, it takes 4 years for it to double. Okay? A single cell amoeba doubles every 6 days. How long does it take to produce 2,500? Okay? So, how long does it take 1 to get to 2,500? So y equals, we start out with 1, and it's going to double every 6 days. So it's going to be the time divided by 6. So in 6 days, we'll have 2, and so on. Okay? So then, how long will it take to get to 2,500? So, again, graphing calculator. I'm going to clear these out and go 1 times 2 is really 2 raised to the x divided by 6 power. And I want to go to where it equals 2,500. So my window, I can leave it there. But this one, I'm going to go to 2,600 here for my y. So I see my graph there. My other one comes across, and I want to find out where it intersects. Intersects at 67.7 or 68 days. Okay. All right, now we're to the easy log ones. The log of 8, the base of 8 is 64 equals y. So 8 to the y equals 64. Okay? What would y have to be? 2. The log of 10 to the 19. What's the base of a logarithm, a common logarithm? 10. So 10 to the x equals 10 to the 19th. What is x? 19. See that, Shanty? Yeah. All right, good. What's the base of a natural log? What's the base down here of a natural log? E. So e to the x equals e to the negative 1. So what does x equal? Negative 1. The ln of 1 over e to the third is the same as the ln of e to the negative third, correct? So if e is here and we put an x here, e to the x equals e to the negative 3. So x equals negative 3. 10 to the log cancels each other out. So we're just at 0.5. E to the ln cancels each other out. So we're just at 12. And this one's just a total calculator problem. Okay? So you just, on your calculator, take the log. Oh, clear. The log of 0.183. And it's negative 0.738. Okay. And, oh, we have 21 questions, not just 20. 21. The log function. Okay, compared to the log function, this is 5 plus that. So 5 plus that means we're going to translate the graph up 5 units. And you just graph log equals 5 to the x. So then it's just going to come up somewhere like that. I don't know the exact numbers. It has the graphing tool on that will put you where you need to be. You just have to know that if it's plus something, that it goes up by 5. Okay? Your assignment's out there actually already. Which one? All right. So that is it. You need to do the practice test now. Do not do other things and then say,